How can internal combustion engine exhaust emissions be reduced? Imagine driving your car and knowing that it's doing its part to keep the air cleaner. That's what reducing exhaust emissions from internal combustion engines is all about. These engines burn fuel to produce power, but they also create pollutants like nitrogen oxides, carbon monoxide, and burned hydrocarbons, and soot. The good news is that scientists and engineers have found ways to cut down these harmful emissions significantly. One way is to make the combustion process inside the engine more complete and cleaner. This involves designing the combustion chamber differently so that fuel and air mix better and burn more efficiently. Precise control of fuel injection, timing, and spray patterns helps ensure that fuel burns fully, reducing leftover and burned fuel. Adjusting how much air enters the engine and how it moves inside the cylinders also improves combustion quality. Recirculating some exhaust gases back into the intake air, known as exhaust gas recirculation, lowers the combustion temperature. This process helps cut down on nitrogen oxides, which form at high temperatures. Adding water into the combustion chamber can also help by lowering peak temperatures and further reducing nitrogen oxides. Even with these improvements, some pollutants still escape with the exhaust gases. That's where after-treatment systems come into play. Catalytic converters are a key part. They use special catalysts to turn harmful gases like carbon monoxide and burned hydrocarbons and nitrogen oxides into less harmful substances such as carbon dioxide, nitrogen, and water vapor. Diesel engines often use particulate filters to trap soot and other particles, which are then burned off during regeneration. For nitrogen oxides, systems like selective catalytic reduction inject a urea-based solution into the exhaust. This reacts with nitrogen oxides and converts them into harmless nitrogen and water. For engines running on natural gas, devices are used to reduce and burned methane in the exhaust. Advances in materials also help reduce emissions. High-temperature turbochargers recover more energy from exhaust gases, boosting engine efficiency and lowering emissions. Catalysts that work at lower temperatures ensure that emission control remains effective even as engines become more efficient and produce cooler exhaust gases. Adjusting engine operation strategies, like changing valve timing and cooling water temperature, can also influence emissions and fuel use. These tweaks help find a balance between reducing pollutants and keeping the engine running smoothly. Looking ahead, switching to electric vehicles or alternative fuels offers a way to eliminate exhaust emissions altogether. While this is a larger change, it shows the direction the industry is heading. In the end, reducing exhaust emissions from internal combustion engines involves a mix of better combustion techniques, effective after-treatment systems, advanced materials, and smart engine management. All these steps work together to make engines cleaner and more efficient, helping us breathe easier and protect the environment.